Mr. Dueck is purchasing a new Lamborghini sports car. Yeah, right. Well, we're in our magic physics world, as I would say in my physics classes, so it's all magical. He has a choice of 6 colors, 3 body styles, 4 interior packages, and 5 tire styles. How many different choices of Lamborghini sports car are there?
5 tire styles?
3 tire styles. There's a Freudian slip. I'm dreaming about my Lamborghini. I think it's 6, 3, 4, 3. Is that right? Now, how could I give you, your test is going to have some multiple choice, and since we're getting towards the unit, I'll start giving you hints about the test. How could I turn this into a multiple choice question? Well, one way would be to actually have the answer, but another way might be to have as one answer. That might be another. I could come up with all sorts of silly ways to do this. I could maybe have 6p3, 4p3 as an answer. So just, kind of ways that I can try and muck you up. Meanwhile, it's going to be 6 times 3, 18 times 12. Maybe I can do this a little better. It's going to be 36 times 9, which is going to be 360, take away 36. 324? Is that right? I'm in my head. I could be wrong. 216. Wow, am I that off? Oh, it's 24 times 9, not 34. Geez, Dueck. 24 times 9. 24 times 10 will be 250. Take away 24. 216. That's what I should have said. Yeah, I'm off. I'm still disturbed over my many lates this morning. 1 mark. I don't know why I thought of this word when I was thinking about you and making up this quiz, but how many ways are there to arrange letters of the word complainers? What I now have to ask myself whenever they give me letters in a word and use the word arrange, which is my trigger word for the fact that it's permutation, I have to check first, are there any letters that appear more than once? No? Then I can use the easiest shortcut. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it 11 factorial? Which is what? I got my TI open. 11, math. Factorial. 399, 168, and 2 zeros? Two zeros. Good gosh, Dueck. How many 7-letter arrangements? Okay, the trigger word is arrangements. That tells me it's a permutation. Only this time we're only picking 7 at a time. Are there of the word ambidextrous? Is every letter different in the word ambidextrous? It is. Okay, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can go from 12, permutate 7, which is the shortest way. Or I could draw 7 blanks. And it would be you have 12 letters, then 11 letters, then 10 letters, then 9, then 8, then 7, then 6. Or remember what 12p7 means. It really means 12 factorial over not 7 factorial, 5 factorial over 12 take away 7 factorial. And hopefully by doing it that way, you can see why this is the same as that. Because it's 12 times 10, 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 on the top, divided by 5 times 4 times 3 times 1 times 5 times 4 times 3 times 2 times 1 on the bottom. Those would cancel, and I'd have the 6 through 12 left behind. Anyways, what's the answer? 3,991,000. Just give me the digits.
3,991.
It's the same as the top one?
Same answer as number 2, but
With one less zero. That's a complete fluke, by the way.
Not right-handed. Oh, okay.
Oh, what does ambidextrous mean?
Yeah, you just answered the question.
So, stupid nerd tricks. I'm a lefty. I can write backwards fairly easily, not very neatly, but I can write backwards almost as fast as I write forwards because who's my righties here? Who's right-handed? That's how you all write from the inside of your body outwards. As a lefty, I write from the outside of my body inwards, but writing backwards, oh, that feels great. I can go from the inside outwards. I used to often cramp up on essay exams, for example, because I had to write that way. Oh, boy. Stupid party trick. President James A. Garfield, who I think was the 3rd president of the United States, used to, at parties, as a trick, hold a pen in his right hand, hold another pen in his left hand, and while someone dictated to him in English, with his right hand he would translate into Latin, whilst simultaneously with his left hand translating into Greek. That's a pretty impressive, useless, but pretty impressive party trick. How many 3-letter arrangements can I make from the word campgrounds? Any letters appear more than once? No. Okay, then it's 11P3. Wait a minute. I don't see that there. On the formula sheet that I gave you, it turns out 11P3, well, it turns out NPR is defined as n factorial all over n minus r factorial. That's how we defined the permutation shortcut. That's why it works. So I guess 11P3 is the same as 11 factorial all over 11 take away 3 factorial. Except what's 11 take away 3 in your head, Jordan? C. That gives you an idea of how I could turn this into a multiple choice question and force you to do a little bit of thinking and a little less plug and chug on your calculator. Turn the page. How many 4-digit numbers can I make from the following group? Okay, there's my Scrabble bag. How many digits? 4-digit numbers. I'm going to draw a blank. I'm good at drawing a blank. Any other restrictions? How many choices do I have for the first digit? Don't say 6, because I don't. I heard 5, I heard 4. 5? Why can't I use 6? Okay, we're going to say you don't start with a 0. Otherwise, the answer to all of these is sort of infinity, because then you could say, why can't I start with 2 zeros or 3 zeros or 4 zeros? Okay, fine. So I have not 0, 5 choices. Maybe I picked 5. How many choices do I have for the next blank? Any restrictions anymore? How many choices? Then 3. Now, if you did it that way, I'm going to give you full marks. But Dom is pointing out, he said, Mr. Dueck, you didn't say that we couldn't use the same letters. This is a poorly written question. I didn't say whether repetition was allowed or not. So if you went, because you assumed you could throw the letter back in the number back in the Scrabble bag and shake it up again each time, I will also give you full marks for that. This is a poorly written question on purpose, because it lends good discussion. Do you see why we can't be certain? I didn't say whether you had to not reuse a number or not. So I'll accept 25 times 12, 300. Is it 300? And I'll accept 5 times 6 times 6 times 6. 6 times 6 times 6 is 216 times 5 is going to be 1,000. Is it 1,080? Don't quote me on that, but double check me. Is it? I think I've made up for my 216 or 200 and whatever blunder on the previous page. That 1,080 was pretty good. How many permutations are there of the word Mississippi? Do some letters... Oh, yeah. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's going to be 11 factorial over how many M's? 1. How many I's? 4 I's, 4 S's, 2 P's. Let's evaluate that. You know what? I'm going to close my TI. It's just too painfully clunky for this. Let's bring back my Casio. Oh, yeah. Option, more, probability. Okay. 11 factorial divided by bracket 4 factorial times 4 factorial times 2 factorial. Do you get 34,650? Okay. By the way, if I'm good at arithmetic, Alyssa, I could also have gone 11 factorial divided by bracket 24 times 24 times 2, because I can go 4 times 3 times 2 times 1 in my head. Same thing. 34,650. What if I said, how many 4-letter permutations are there of the word Mississippi? In all honesty, that's a fairly nasty question, and it would require an entirely separate lesson, and I'm not going to do it. So if I give you, Chelsea, the same letter appearing in a word, it's going to be, yeah, give me the whole word. Okay? At least for now. How many permutations are there of the word Chilliwack? Do some letters repeat more than once? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it 10 factorial over 2 C's? How many H's? 2 I's, 2 L's, 1 W, 1 A, 1 K. Is it that? Which is going to be 10 factorial divided by 2 times 2 times 2. Mr. Dueck, you forgot the factorial. Oh, what is 2 factorial? It's 2. Often I'm lazy enough that for 2 factorial, Jake, often I won't even bother putting the factorial because 2 factorial is 2. Do you get 453,600? Pathway questions. I like pathway questions. How many pathways are possible from A to B? But I have to always add this condition. You got to keep moving closer to your destination, which in this case is right or down. Well, I guess I would go right 4 times in any path, and I would go down 1, 2, 3, 4, 5, 6, 7 times. I might not go all rights and then all downs. I could mix them up. Did I say mix them up? That sounds like an arrangement, a permutation. How many letters are there in this word? I think 11. How many R's are there? How many downs are there? By the way, in a wonderful coincidence, what does the bottom add to? You know what that actually means? It actually means if you're looking for an even shorter cut, this is 11 choose 4. Because if you look on your formula sheet, n choose r was n factorial over r factorial n minus r factorial, which I think fits that pattern. You don't have to use the choose, but for what it's worth, it's kind of nice. Holy smokes, I got a shortcut for a shortcut. It is 330, yeah? No matter which way you do it? Mm-hmm. Put your pencils down. Don't turn the page over. Look at this question. One more very cool way that you can do these. Don't write this down, but for what it's worth, you put a 1 here. You put a 1 here, you put a 1 here. You put a 1 here, but here you're going to add up the numbers coming into it. I got a 1 this way, I got a 1 this way. What's 1 plus 1? Put a 1 here. Because what you're really imagining is out here there's a 0. What's 0 plus 1? 1. Right here, what's 1 plus 2? What's 2 plus 1? What's 1 plus nothing? What's 1 plus nothing? 1. What's 1 plus 3? 3 plus 3. 3 plus 1. 1 plus nothing. 1 plus nothing. 1 plus 4. 5. 10. 10. 5. What's 1 plus nothing? 1. 1 plus 5, 6, 15, 20, 15. Where are you going with this, Mr. Dueck? Patience, young grasshoppers. 1 plus nothing, 1, 7, 21, 35, 35. What's 1 plus 7? What's 7 plus 21? 28. 21 and 35, 56, 35 and 35, 70, 8 and 28. Stay with me, Matt. 36, 28 and 56. That'd be 78 plus 6, 84. 56 and 70, 126. 36 and 84, 120, 84, and 126. 210. 210 plus 120, Mackenzie, is what? Are you kidding me? Now, I would never do that one that way, but you may recall in the homework there was some weird irregular ones that I said we didn't know how to do because they overlapped weirdly. That method that I just showed you works for any pathway. And I love the fact that the math involved is honkin' grade 3 adding. Yet it solves a grade 12 nasty question. It's not quick, but it's cool. Can you give yourself a clear score, please? Out of 8. And aside from the people that were away, pass them inwards. Turn to page 91. Page 91. Under the B, 9. Under the I, 1. And then Brianna, can you do me a favor? And yeah, it's better. Thank you, because that looked pretty out of it. And it spreads. It's contagious. And I want you to look at example 4, a taxi company. Now, example 4, a taxi company, we can't solve using permutations with repetitions because it's not two completely separate sections. So this previous one, example 3, we did together. We said that one because it's two completely separate rectangles. We can treat one, treat the other, and then just multiply them together. Rotate your textbook about 90 degrees so that the train station is on top and the football stadium is below. Trust me, it helps to just spin your textbook about 90 degrees. I can't do that with my screen, unfortunately. And we're using a method called Pascal's triangle to solve these. So what I'd like you to do with me is take your pencil out, and on the train station, right there, put a 1 right where the lines cross. And then what we're going to do is we're going to move down the grid, adding the two diagonal grids above to get the next total. Now, right here, there is a number sitting right here. It's invisible. What? 0. So this is going to be 1 plus 0. What's going to go right here? 1. And right here, what's sitting here? It's invisible. It's going to be 1 plus 0. What's this square going to be? 1. In fact, on the next level, there's going to be a 1 here. But what's this middle square right here going to be? See it? 2. How about here? 1, because it's 1 plus nothing. How about right here? 1 coming in, nothing coming in. What's this square going to be? Hopefully you can see the pen cursor. What's that square going to be? 1. What about the next square? Right here. 3. See it? What about the next square? Do you see, by the way, do you see why I had you rotate your book? That way you can just move straight across, right? A little easier. And I used to be able to flip the screen and do funky things, but last time I did that, I lost my pen ability, so I'm not going to risk that again. 3, right? And how about this top corner square up here? Just a 1. Zoom, move back. What about this bottom corner square? 1. What about this next square? 4. Then? I heard it. Yep. 6. Then? 4. Oh, I guess there's no, I can't move up diagonally. Back down to the bottom. Ooh, what about this square right here? What's flowing? What? You're right. 5, right? Then 10, then 10, then, well, it's a 4 coming in, and what number is sitting right here? It's invisible. 0, so it's going to be a 4 again. By the way, when you do a bunch of these, you just start cluing in the sides slide down, but I'm pointing out to you the reason they slide down is it's technically 4 plus nothing. Right? Right here. Jake. Yep. Then. Right here. Okay. I got a 15 plus what's sitting right here? Oh, so just a 15? Then, right here, 35. Then, 34. How about right here? 50, 50. Next one, right here. And then finally, do you know how many paths there are? Add them up. 119. Okay. Irregular pathway problems. Again, the nerd within me, Oscar, loves that we're solving Math 12 with grade 2 and 3. It's literally add two numbers together and keep track of it. But that works. Actually, that would also work, by the way, for this one. If you carefully added your way down, you would get the same answer that you would with the shortcut. So part of your homework that I'm going to add to from this lesson now is, I think there was a couple of irregular pathway questions, if I recalls. Or were there? Ah, yeah. So part of the homework, I'm going to say you can try number 8. And by the way, although it says you're going from A to B, if you start at B and go to A, you'll get the same answer. And sometimes one direction is way easier than another direction. So you can go from A to B or B to A. It won't make a difference. A, I'd go from, in fact, probably part C, I might be tempted to go from here this way. I don't know. I'd have to think about it. Okay, so that's part of our homework. Now, we're going to finish off also the lesson from last day, which was, hey, Paige. Oh, you know what I just did? I messed up my original documents. That was silly of me, Mr. Dueck. So that was here. I'm going to delete that. Dunk. And I'm going to delete all of this, Mr. Dueck. That wasn't very smart. I want to be in block D. That's why I didn't have any notes all of a sudden. So lesson 6, we were on page 104. I'm going to talk for a bit and then I'm going to shut up. What I want to also try and do today is a homework check from lessons 1 to 6. Someone said, hey, Mr. Dueck, you haven't sent a math grade update out lately. No, because I haven't done a homework check lately. So if you're wondering why I'm doing the homework check, you can blame Brendan. Although I think I blamed somebody else last time. Did I blame Kyle last time?
Yeah, Kyle.
Okay, so you know what? Bonson Park, 3 o'clock, Brendan and Kyle. If I'm not there, start without me, right? Okay, here we go. So we've looked at the key idea from last lesson, and Brendan, you were away, so you want to pay attention. I'm absolutely on your test going to give you questions with the words at most or at least. List the cases. Don't try and do it all in your head. List the cases. List the possibilities. Then underneath each case, remember that or means add. And you can usually use the same bucket for all of them by just tweaking the bucket. So you may recall we said, okay, as an example, I did at most 2 kings. And I said at most 2 kings means 2 or 1 or 0. I did 2 kings, then 1 king, then 0 kings, all from the same bucket. And I said or means add means multiply. Gonna make it, Pam? Good, sit up. So the last thing I want to talk about is solving for n in combination problems, figuring out how many objects there have to be. During a P-way tryout, all the players met on the ice after the last practice, and they shook hands with each other. There were a total of 300 handshakes. A says, write an equation whose solution would determine the number of players on the ice. I'm going to give you a hint. There's your hint. It equals 300. I can do a little better than that. When you shake hands, how many people shake hands at a time? Do I care about the order, or do I just care whether or not they shook hands? It's a choose. I don't know how many people, but if I choose 2 at a time, apparently I had 300 handshakes. solving for n. One way to solve for n is purely guess and check. How many kids do you think there are? 20, choose 2, higher. 25, choose 2. Oh, there. N's 25. That's purely guess and check. I'll be honest, that's the fastest way. In fact, back when this used to be part of the old Math 12 course and there was a provincial, I taught my kids if this was a multiple choice question, just plug in all 4 answers from your multiple choice. Don't even guess and check. Plug in the 4 answers that are there. One of them's got to work. But you can also do this algebraically. Oh, hang on, I can't say 25 exclamation point. I can't use an exclamation point to emphasize anymore because you guys will all think it's factorial. N equals 25, double underline. There's my exclamation point, I guess. Who has their formula sheet handy? What is N choose R? And if you want to, you can write it up here in the corner. N choose R is defined as, Ben, you got it?
Yep.
What?
N factorial over R factorial, and then in brackets, N minus R factorial.
Write that down in the top corner. N choose R is defined as, this is what your calculator is doing for you quickly, N factorial all over R factorial, N minus R factorial, which means in this particular case, N factorial over 2 factorial, N minus 2 factorial equals 300. And all I've done, Laura, is do a substitute, plugging everything in, substituting everything in. N is N, R is 2, N minus 2 is, N minus 2. By the way, what is 2 factorial the same as? See how I worked that in earlier? Wasn't that smooth? You know what then? I'm just going to temporarily go, even though it's a factorial, I'll do that. Why? I want to keep the factorials on one side and get everything else to the other side. How could I move that 2 that's on the bottom to the other side? Dividing by 2 on the left is the same as, my physics kids should be able to do this kind of in their sleep, yeah?
2 over 2.
So instead of a 300, what will I have over there? More specific.
600.
Thank you, Captain Obvious. So here's what I have in my next line. As an equation, I have this. N factorial over N minus 2 factorial is 600. You guys can be writing this down now, right? Because I gave you notes with, right? Right? Right. Problem is, Mark, there's no way to do math with factorials. Wait a minute, though. If I'm clever, I can get them to cancel. Mark, what's on the top on the left-hand side? What's on the bottom on the left-hand side? Just read it to me. N minus 2. What's bigger, N or N minus 2? What's bigger, folks, N or N minus 2? So I'm going to start to expand that one. My next step, I'm going to say N factorial is really N times 1 less than that. How would I write 1 less than N? In brackets, N minus 1 times 1 less than that. How would I write 1 less than N minus 1? In brackets. Why would I stop here? Mark, what did you say I had on the bottom in as a factorial? And what did I just write on the top now when I started to expand? I wrote an N, I wrote an N minus 1, but what have I just written right now? You know what? I'll just replace everything else with a factorial. I'll leave the N minus 2 factorial here in brackets. That equals 600. How many N minus 2 factorials do I have on the top? 1. How many do I have on the bottom? 1. Can I cancel? Is it factored? It's factorial. It is canceled. It is factored. And now I end up with this equation. Sorry, I'm kind of running out of room here, but N bracket N minus 1 equals 600. Now what? N squared minus n equals 600. Hey! What kind of an equation is this? Quadratic. How do I know? It's got a squared. How do I solve a quadratic? Before I do anything else, what do I have to do? Make it equal to 0. How would I make this one equal to 0? Yep. With me, Karn? You're not foolish looking at your phone or something like that, since I see your calculator on your desk and you're staring at something very, very intently. I would never be so foolish as to think I can game Mr. Dueck. At least I would have my calculator on my lap and my phone on top of my calculator so that Dueck thinks I'm staring at my calculator. That's what I would do. Karn, how would I get the, how would I make this equal to 0? You were zoning out. Yeah, I'm picking on you. Told you I'm in a grumpy mood today and you were foolish. What kind of an equation is this? Help me out, folks. What kind of an equation is this? Quadratic. How do I know? Got to square it. See it? See it? See it? See it? See it? How do I solve a quadratic? First thing I got to do is make it equal to 0. How? Oscar, my friend, how? Pray? No, that's not going to help you. Sorry to be picking on you guys, but you guys were zoning out. Minus 600 from both sides. Okay? I get this. N squared minus n minus 600 equals 0. Now what? It factors, or you can quadratic formula it. Have you got a quadratic solver on your, you do? Go ahead and use the quadratic solver. Mr. Dueck, why don't you just let us guess and check? It's faster. It can be faster. Can be slower. Or if I'm really mean, I'll give you one that's too big for your calculator to handle. Remember, we noticed it started to fry at around 70 factorial. What are the roots? Not 24 and 25. Can't be 24 and 25. One's got to be positive, one's got to be negative. I don't think it's negative 25. Is it not positive 25 and negative 24? Or is it the other way around?
No, you got it right. It's positive 25 and negative 24.
Right? Yeah. What's wrong with the negative 24? Can I have negative 24 students?
No.
So, reject. Much like whose date? Jake's date. Oh, there you go. Okay. What's faster, guessing or doing it algebraically? Well, you know what? I might force you to do one algebraically. I might say, guess, but for 2 marks, prove it. What's your homework? I already assigned 1, 2, 3, 4, 5, 6. You can try, 4, 5. You can try 6 now. I have one beef. Can you all look up? Can you look at 6C? 6C says 11 choose what? You know what? Cross out the n, make it an r, because that's the variable that we've used. We used n for the first variable. We used r for the second variable. That's me being very peevy. And you know what? Guess and check for that one. That one is very tough to solve algebraically. You can try number 7. This is a handshake question. And I think we'll pause there. So you got 15 minutes. Work on the homework.